Hey everybody, welcome back to Math 20-1. We are at the Inequalities and Systems of Equations unit, and we are on the next lesson, solving systems algebraically. Remember, at the beginning of every note package is a list of things that you should be able to do or answer at the end of every lesson. Have a moment to read this over and keep these things in mind as we work through the examples. So let's get started. So you might remember that in Math 10C, you did learn how to solve systems of linear equations. And those were equations that have the form y equals mx plus b. And you solve them algebraically using substitution or elimination. Now, elimination is sometimes called addition. Now, we are going to be looking at these two strategies for solving systems of equations in Math 20-1, but these are going to involve the quadratic equations, and as we all know, those are equations of the form y equals ax squared plus bx plus c. Now, let's consider the equation below. Why can't you just find the value of x? So what's the problem? We have 3x squared minus y equals 9. Well, you may be saying that, well, we can't say what x or y is because we don't know what the other one is. For instance, we don't know what y is to isolate the x, and we don't know what x is to isolate the y. In other words, there are two things we don't know in one equation, so we can't solve it. But now let's consider the system of equations. We have the same equation here, but now we've added this other one of x plus 2y equals negative 4. Now, while there is still two unknowns, we now have two equations with those variables. Now recall that the solution to a system of equations is the one set of values, x and y, that we can plug in, and they are going to make both equations true at the same time. So we don't know what x and y are yet, but we do know they're the same for each equation. Now for this lesson, our guiding principle will be create an equation with one unknown value, and then we can find what that one is. Now we're going to do it through the two methods that we learned about in 10C. First one is solving by substitution. In substitution, we choose one of the equations and we isolate one variable in this equation, and generally look for what's easiest. We're going to then substitute the expression for the variable that you found in the previous step into the other equation. When you do this, you have gotten rid of one of the variables. Now you can solve for that single variable equation. Just keep in mind, now we are working with quadratics, so this may involve factoring or using quadratic formula. But we know all about that now. We're going to then substitute that solution into the other equation to find the other variable. And that's the method of substitution, and we're going to look at some examples of that. The other one is elimination or addition. Now, this involves a little bit of algebra up front. We're rearranging both equations if necessary because we want to line up the variables. The next thing we're going to do is we're going to then multiply both sides of one equation by a strategically chosen constant. You want one variable to end up with the same coefficient. So this is the key to elimination. This one right here. We want one variable to end up with the same coefficient. But we want it to have opposite signs. So then we're either going to add or subtract. We're going to stick mostly to adding. Well, if you have learned subtracting and you're comfortable with that, you can definitely go ahead and use that. And we are going to eliminate one of the variables. Now, if you make the variables to have the exact same coefficient from the previous step using that specially chosen constant, we're going to subtract. And if you make them opposites, so they have the same number but opposite signs, we're going to add them. When that happens, you're going to see that one of the variables gets eliminated. And then we can solve the resulting equation to determine the one variable. Now, sometimes this is quadratics, so we may involve factoring or the quadratic formula. And then we're going to substitute it just like we did in substitution for the last step to find the other variable. So let's tune up some of those Math 10C skills, and we're going to work through solving this system of linear equations using both substitution and elimination. So let's start by going into substitution. And just to give me a little bit more room, let's do that. There we go. Okay. So we have this system of equations, y equals 3x minus 6, and y equals 2x plus 7. Now in this one, it's actually pretty quick to get rid of them because these are both already have y on one side. So we get to pick our favorite. Let's pick y equals 2x plus 1. So we didn't even have to do anything. We already have it solved for y. Well, now this y equals 2x plus 1, this part here, we're going to substitute for the y in the other equation. So let's go down. And I'm just going to rewrite that here. And I'll write the other equation right here. So what I'm going to do, wherever there's a y in equation 2, I'm going to take this thing right here and put it in there. So now what do we end up with? Well, now when I make that substitution, I have 2x plus 1 equals 3x minus 6. I've substituted one expression for y into y in the other equation. So now we can solve for x. So let's go ahead and do that. A good strategy for doing this is to look for the side with the biggest variable coefficient with the variable, the 3x, and that means I'm going to go to the other side and subtract the 2x from that side, which means I'm going to take that 6 and add it to both sides. So doing this, what I'm doing is isolating the x terms and isolating the constant terms. So these get canceled. And now I'm left with 1 plus 6 on this side and 3x plus a negative 2, which is 1x on this side. And I've solved for x. So now that we have this x, we're ready to return to our expression for y from a few steps back and solve for the y. So we're going to go ahead, and at this point you can pick either equation. We can start with the y equals 2x plus 1, And then we can solve by substituting that value of x into here. And that gives us y equals 14 plus 1, which is 15. Or we can do it with the other equation. So I say y equals 3 times 7 minus 6, y equals 21 minus 6, and y equals 15. So as you can see, we've gotten the same y value regardless of which equation we decided to substitute our known x in for now. Well, the last step is we want to make sure that these actually do solve the equation. So we would say our solution is 7 and 15 as an ordered pair. So we're going to substitute them into the original equations to make sure it works. If we have y equals 2x plus 1, I want to make sure that the right-hand side equals the left-hand side. So wherever there's a y, I put the 15. Wherever there's an x, I put the 7. And sure enough, 14 plus 1 equals 15. So we know it actually is a solution for the first equation. But it's not enough just to test one equation. You want to make sure you've done it for both. I've seen cases where I've made a mistake, and although it worked at the end to verify the first equation, when I tried the second, I made a mistake, and that's how I caught it. So we're always going to check both. So we have y equals 3x minus 6, and I plug in my 15, and I say 3 times x again is 7 minus 6. 3 times 7 is 21 minus 6, which is 15. So we know we've done it right. Well, let's do the same equation. We're going to roll back up, and this time we're going to do it using elimination. Now, when solving by elimination, the first thing we want to do is rearrange the questions in order to line up our variables. In other words, it's like we have columns of variables. So the nice thing about this one, if I write y equals 3x minus 6, and then if I write this one just below it, these are already in nice columns. Look at what we got here. We could say this is the first column, and notice the y's are in that column, and this is the second column. The x terms are there, and then we have these constants at the end. So we have these nice columns already, so we don't have to worry about doing those. So now that we have them in these nice columns, we need to add or subtract these things to eliminate one of the variables. So remember, the idea is we want to add or subtract, but we're going to stick with add, these two equations together in order to eliminate one of the variables. Now, in this case, notice that the y's have the same variable in front. They have that hidden 1. We don't write it in there, but we assume it to be there. So we have one y there and one y there. Now, that means we need to multiply y by -1 in order for it to cancel. But the thing is, when we multiply one part of an equation by a number, we have to multiply all parts of an equation by that number. So that means in order to subtract everything or add everything, my bad, we actually have to write down the first equation, y equals 3x minus 6. And then we're going to write down the equation where we're distributing the y through all the terms. So this is going to give us negative y equals negative 2x minus 1. Now we're going to add these two together. So y plus a negative y, that's a big old 0. And then 3x plus negative 2x is x, or 1x, and negative 6 plus a negative 1 is a negative 7. So now we have created an equation with only one unknown, so now we can solve for x. And to do that, we have to isolate the x by adding 7 to both sides. So now we have 7 equals x, or if you wish, x equals 7. So now we're ready to substitute the x equals to 7 into one of the original equations. And this is really like the last part of the substitution method. So in other words, we just go ahead, pick an equation, substitute in, and solve for y. And notice this is exactly the same as what we did over here. Over here. So that's a recap of substitution and elimination. So now let's head on down. And this time we are going to look at some examples that involve the quadratic equations too. Now the strategies are exactly the same. We just have to deal with those squared terms. But we know how to deal with those from the previous unit. So let's look at this example. So it says solve the system of equations y equals x squared and y equals 2 plus x algebraically using substitution. Okay, so let's start. Let's write down y equals x squared and y equals 2 plus x. Well, this is nice because in substitution, we want to isolate one of the variables to substitute into the other equation. Well, in this, we already have isolated the y, so now we can go ahead and substitute it into the y of the second equation. So this is going to give us x squared equals 2 plus x. Now this should be looking pretty familiar to you right now. We have looked at solving quadratic equations a lot. And we remember that the first thing that we're going to do when we solve quadratic equations is that we are going to get all the stuff to one side. So that means I'm going to subtract 2 from both sides, and I'm going to subtract x from both sides. And that gives me x squared minus x minus 2 equals 0. Well, we know how to solve this too. We know how to factor this to solve for x. So we're going to look for two numbers, m and n, that multiply together to make the last c value, which is negative 2. And we are going to add those two numbers together so that they equal negative 1. Well, that means we have a negative 2 times a positive 1 is negative 2, and negative 2 plus 1 is negative 1. So now we have our two factors. And that gives us those little mini equations we're going to solve. We're going to say x minus 2 equals 0. So adding 2 to both sides, we get x equals 2. And then for the other one, we got the mini equation x plus 1 equals 0. And then we're going to solve for that by subtracting 1 from both sides to give us x equal 1. Well, now look at what we have here. We have two values of x's, and we know that if we have two values of x's, we can definitely find the corresponding y's. So let's go ahead and look at that. So let's find the y's. Step 3. Oops, almost forgot the negative on my 1. Okay, so now we have these two values of x, which means we potentially have two values of y. So let's find the y's. So we're going to start by substituting the 2 into one of the equations. Let's pick y equals x squared. So we go ahead and we substitute in the 2, and we get 4. So that means one of the solutions as an ordered pair is 2 and 4. Let's repeat the process for the x equal to negative 1. Well, y equals negative 1 squared, which equals 1. So this solution is negative 1 and 1. So now let's verify the solutions. That's the last step. So we need to verify both solutions in both equations. So if we take y equals x squared, we want to make sure that when we substitute the value in for y and x, that the right-hand side equals the left-hand side. Now, in the first solution, y equals 4 and x equals 2. And sure enough, that works. Now let's try the other point. In the point negative 1 and 1, y is positive 1, x is negative 1, but when we square it, we get positive 1, and the right-hand side equals the left-hand side. We're going to repeat the process with y and 2 plus x. And we're going to do it with both solutions. So for this one, we got 4 and 2. So we say 2 plus 2, and that equals 4. So these are equal. Let's do it again with negative 1 and 1. Here we get 2 plus a negative 1, which is the same as 2 minus 1, which is positive 1. And there again, we have the two solutions that are verified with the two equations. Now, in the instructions here, this would be as if it were a numeric response type question. Notice we have A, B, negative C, and D. Well, in this format of A, B, and I'll just write it down here, negative C and D, if we compare our two solutions, 2 and 4, and negative 1 and 1, notice that A must equal 2, B must equal 4, the C equals the positive 1 because we already have this negative 1 here in front, and the D equals 1. So in a numeric response situation, we would put in 2, 4, 1, and 1. Because remember, there's no place for a negative sign in a numeric response answer. Okay, let's solve the following system of equations algebraically, but this time we're going to use elimination and verify the solutions. Now, the first thing we're going to do is we're going to line up the variables. Remember, we said we're going to put things into columns. The difference with the quadratics is we're going to have more than one x column. We're going to have a column of x squareds and a column of x's. So it's going to kind of look like this. We're going to say y equals. Now I'm going to leave a space here because we do not have an x squared term right there. And then I'm going to say 5x minus 10. I'm going to put 2y right here so that our y's are in a column. Now I have this space here for an x squared, and I have an x to follow, but I have no constants right here. So as you can see, we have these nice little columns of y's. This is the column of the x squared, the column of the x's, and the column of the constants. So now let's go ahead and kind of analyze the coefficients of the x's or the y's. Well, in this particular example, we can't eliminate the x's because we have an x squared and an x. So the only option is to eliminate the y. But the y's do not have the same coefficient. So the way that we can make the y's equal and opposite in sign is by multiplying the first equation by -2. Because the coefficient here is 2 and opposite of 2 is -2. So I'm going to multiply all of those things in that equation to make -2y equals, well, there's still nothing in this place right here. We can kind of leave it blank. Minus 10x plus 20. Now this one we're just going to rewrite as it is. Now we're going to add this up, be sure that we add up all the columns. So -2y plus 2y is 0. Now we have nothing right here, and if you like to put a 0 there so that you can see 0 plus x squared, well, that's just x squared, you do that. -10x plus x, well, that's -9x. And 20 plus 0, because there's nothing in this spot, is 20. Now we're back to the idea that we're going to solve to find x. So we've lined up everything right here, lined up, and multiplied to eliminate. Now the next one, we're eliminating. So we're eliminating by adding. Oops, I put that too far down. Eliminate by adding. Now the third step is we're going to solve for x. And we can do it in a variety of ways. We could factor, we can use the quadratic equation. So because this has small numbers, let's go ahead and factor. Because a equals 1, we're going to use the same method of 0 equals two binomial factors, x times something and x times something. We're going to look for two numbers, m times n, and that's going to give us a positive 20. And then we're going to say m plus n is going to give us that middle term of -9. Now notice here we have a positive 20, and only two positives can make a positive. Oops, that's x. Or two negatives can make a positive. So that must mean m and n must both be negative. Well, two numbers that multiply to 20 but add to -9 are -5 and -4. So now we have our two little mini equations. So we're going to solve for x by adding 5 to both sides. And now we're going to solve x minus 4 equals 0 by adding 4 to both sides. So we have two solutions, x equals 5 and x equals 4. Well, now we're going to find the y's, and we're going to find two of them because we have two values of x's. So we're going to pick an equation and substitute the x's in. Now remember, work smart, not hard. Pick the easier ones. I'm going to pick y equals 5x minus 10. So I start with this equation, and I substitute in my first x so that I get 5 times 5 minus 10, which equals 25, minus 10, which equals 15. I'm going to do that again for the next value of x. So I'm going to say 5 times 4 minus 10, which equals 20 minus 10, which equals 10. So now I have my two solutions. I have 5 and 15, and the other one is 4 and 10. So these are the two solutions. Well, let's verify. So we're going to go ahead. We're going to start with y equals 5x minus 10. And we're going to put our 5 for the first point in here and substitute the x to get 25 minus 10 to get 15. And that worked. And we're going to do the same thing with 4 and 10. We're going to put our 10 right here. 5 times 4 minus 10 equals 20 minus 10, which equals 10. And that worked right there. Let's do it again, but this time now let's go with the other equation. We have 2y and x squared plus x. Well, this one we have 2 times y, or 2 times 15 for the point 5 and 15. And now we're going to substitute in 5 here and here. Well, 2 times 15 is 30. This gives us 25 plus 5, which gives us 30 here. These two sides are equal. Let's check the other point. So here, again, 2 times the y value of 10, which gives us 20. And then we're substituting in the 4, which is 16 plus 4, which is 20. So we verified that the left-hand side equals the right-hand side, and we're done. Now this question, they want us to solve the following system using elimination and substitution. Now for the elimination method first, the first thing we want to do is do the line up. So we're going to line everything up. That means we're going to have to do a little bit of rearranging. I want to put my y over here and then change every kind of the order around. And this is what it's going to look like. I'm going to say y equals, first comes my square term, then my linear term, or the x term, and then my 6. Then I'm going to line up the y's, the squared terms, the x terms, and then the constants. Now, the next thing I'm going to do is multiply one of the equations to make one of the coefficients equal and opposite. Again, we're going to go with the y. So 2, we're going to multiply, and you get to pick the equation. I'm going to pick to multiply by -1. I'm going to pick this one right here. That means I'm going to get negative y equals negative 4x squared minus 4x, plus 4x, negative 1 times, put that there so you remember what we're doing. We're multiplying everything by that negative 1, which means all the signs are going to flip. And now we're going to have y equal to 6x squared minus x plus 1. Then we're going to add the two together to eliminate. Eliminate. Very bad at spelling. Negative 1 and y, well, that's 0. Negative 4x squared plus 6x squared, that gives us 2x squared. And then 4x plus a negative x is 3x. And then negative 6 plus 1 is negative 5. I do want to point out at this point, there are multiple ways to do it. It depends on the decisions you make to make which equation equal or to multiply by negative 1. You could have multiplied the second equation by negative 1 as well, and you would have gotten a little bit different looking trinomial down here. The signs would have been changed, but that's okay. As long you're going to find out that it all washes out in the end. So let's look at factoring this guy. We're going to factor this guy using, what method are we going to use here? We're going to use decomposition. So in decomposition, we take the a value and the c value and multiply it together. So in this case, we get 2 times negative 5. That equals negative 10. Now we need two factors of negative 10. So in other words, we need to come up with m times n. That equals negative 10. And then those two numbers, when we add them together, they have to equal the b value, which in this case equals 3. So we need two numbers that make m times n, which is negative 10, and two numbers that make 3. Well, because this is a negative number, one of them has to be positive and one of them has to be negative. For instance, 5 and negative 2. And 5 plus negative 2 equals negative 3. So we are going to take our middle term, 3x, and rewrite it as 2x squared plus 5x minus 2x minus 5. This is just the same equation written in a little bit of a different way. The next thing I'm going to do is I'm going to bracket off the first equation, and I'm going to bracket off the second equation. But when I do, because I have this negative here, I'm going to bracket it off and flip the sign of the second one, because now it's like having a negative 1 out front. If I left this as a negative, this negative 5 that was here, then if I distribute this negative 1, because that's what's right there, let me just make it clear that even though this is subtract, it's actually a negative 1. That has to distribute back to get 2x minus 5. So negative 1 times, minus 2x minus 5. So negative 1 times minus 2x is minus 2x. Negative 1 times positive 5 is negative 5. And that's what we want. We have to have that negative 5 there. So now I'm going to factor anything out that's common. In the first two, we have 2x plus 5 is what's left when I factor out an x. Then I'm going to factor out, in this case, nothing. I have already taken out a negative 1, and I'm left with 2x plus 5. And that is a good clue that we've done something right. So now I'm going to factor out the 2x plus 5 and what's left. Well, when I take out the 2x plus 5, I have x minus 1. So notice right here that this x comes here and the negative 1 comes there. So we have two mini equations. The first one is 2x minus 5 equals 0. And solving for x, I add 5 to both sides, and I get 2x equals 5, divide by 2, and one of the solutions is x equals 5 over 2. Now we can leave this as a fraction if you want, or we convert it to the decimal of 2.5. Now let's go to the other one. We have x minus 1 equals 0. So we have x equals 1. Oops, and I realized I made a mistake. Let's go back and fix that. You're probably all yelling at me, like, hey, you wrote it down wrong. Let's go fix it. 2x plus 5, which means 2x equals negative 5 over 2. There we go. That looks better. Okay. Next thing we want to do is we want to figure out our y's. Okay, so let's figure out the y's. Well, the first x, we're going to pick either one of these equations. Okay? Actually, I think I will write it down here. I'm going to say y equals 6 times negative 5 over 2 squared minus negative 5 over 2 plus 1. Now, because both of these were quadratics, not one is better than the other. So let's go ahead and just keep going here. So this is going to be 6 times negative 5 squared is 25. And 2 squared, because that's in the denominator, is 4. So I have 6 times 20 to 5 divided by 4 plus 5 over 2 plus 1. Now, 6 divided by 4 is 3 over 2, so that's 75 over 2 plus 5 over 2. Well, now that's everything is a denominator of 2. I'm going to make that 1 a denominator of 2 as well. And that's going to give me 75 plus 5 plus 2, which is 82 over 2. And that's going to give me 41. So one of the solutions is negative 5 over 2 and 41. Well, let's figure out the other one. So let's figure, I'm just going to write down my steps. This is solve for x. And we're going to solve y. So the other one we're going to take is 1. Now 1's going to be a little bit easier. So we get 6 times 1 squared minus 1 plus 1. Well, 1 squared is 1, so 6 times 1 is 1, minus 1 plus 1. Notice these cancel each other out, so we're left with y equals to 6, which means the other solution is 1 and 6. So we have our two solutions, 1 and 6, and negative 5 over 2 and 41. Now let's do our substitution. Now for substitution, we're going to isolate the y's and substitute that value into the other equation. Well, we can actually go right over to what we figured out for the elimination, and we say y equals minus 4x squared minus 4x plus 6, y equals 6x squared minus x plus 1. And that means we're going to substitute this thing into that y. So that's going to give us 4x squared minus 4x plus 6 equals 6x squared minus x plus 1. Now we have a quadratic equation. Let's get everything to one side and make the other side equal to 0. So I'm going to subtract 4x squared. I'm going to add 4x and subtract 6 from both sides. And that's going to give me 0 equals 2x squared minus plus 3x minus 5. Well, notice that we now have the same equation that we got over here. So after this point in substitution, we are just going to go through the same steps that we did to find those two solutions over here. So we don't have to go through all that. So they are the same steps for elimination. Okay. So I want you guys to give a little bit of a try. Go head on over to your practice work, and I want you to try 3A and 4C. Remember, if you are in the asynchronous class, this is a really great time to get in touch with your teacher and just let them know how things are going. It's also a great time to email your teacher maybe and get some help if you're finding that this is not your thing. They would really love to hear from you. After you do those, come on back and we'll keep going. Well, I hope you had a good time with those questions and that you were able to figure them out. We're going to keep moving on and we're going to go to some problem solving. Students are organizing a car wash to raise money for a field trip. The revenue they will make can be represented by the function R of P equals minus 20p squared plus 50p, where P is the ticket price in dollars. The cost of putting a car wash on will be C of P, which equals 75 minus 30p. It says determine the price of a ticket that will allow the students to break even. Well, what does that mean? Well, when we're selling something, the money that we make isn't always the money we make. The money we take in or the revenue, the profit, our profit is going to equal the money we take in or the revenue. So that's money in. And then it's going to subtract any costs we have because that's the money going out. And the break-even point is when the revenue equals the cost, or in other words, when we have no profit. So in this case, with the formulas that we have, we can say that 0 equals R of P minus C of P. Now there's several ways to tackle this. We can actually go ahead and put in our R of P and then subtract the C of P, so the cost. And when we do that, after we distribute that subtraction sign through the cost expression, we get negative 75 plus 30p, which gives us negative 20p squared plus 80p minus 75. And this is something you've done before in quadratics. Now we can actually solve for x. And find out the values of p's that satisfy this equation. So let's go ahead and let's do some factoring. Well, all of these things here, negative 20, 80, and 75, all have multiples of 5. And in particular, I notice there's a negative here. I'm going to pull out the negative 5. So this is going to give me positive 4p squared. And then we get minus 16p. So 80 divided by negative 5 is negative 16. And 75 divided by negative 5 is going to be positive 15. So now I'm going to factor 4p squared minus 16p plus 15. Now remember, when I factor, I'm going to go 4 times 15 is 60. I need two numbers that multiply to 60 but add to negative 16. So we need two numbers that multiply to 60 but two numbers that add to negative 16. Well, that must mean with the 60, we're multiplying two negative numbers together. So what are the m and n going to be? Well, I know that negative 10 times negative 6 equals positive 60, and that negative 10 minus 6 equals negative 16. So I'm going to take my middle term and rewrite it as the sum of negative 16 and negative 6p. So 4p squared minus 10p minus 6p plus 15. So this is going to get me, I'm going to bracket off the first two terms. I'm going to bracket off the second two terms, but I'm going to switch the sign right here. So notice this is positive right here. Let's factor. I'm going to take out 4p, and that's going to give me, oops, not 4p, 2p. 2p times p minus 5. Now this one here, I have that negative, so I'm going to throw that out front, that subtraction sign. And between 6p and 15, I'm pulling out a 3. So it's going to actually have a negative 3 out front. And that gives me 2p. You're probably thinking, hey, let's do that again. Okay. So it's got that negative 5. We're going to hold on to that. In these first two terms, I'm going to factor out 2p. Well, what's left behind? 4p squared divided by 2p is 2p. Negative 10p divided by 2p, negative 5. Now the next one, we got that negative in the middle. 6p and 15 have a 3 in common, so I'm taking out a 3, which leaves me with 2p minus 5. which is exactly what I was hoping for, which means here I have 2p minus 3 times 2p minus 5. So we have negative 5 times 2p minus 3, 2p minus 5. So now I want to go ahead and solve those little mini equations. And I'm going to get p equals 5 over 2. So I added 5 to both sides. Let's not skip steps. Add 5 to both sides. 2p equals 5. And divide both sides by 2. So now I have one of the p's is 5 over 2. The other p is 2p minus 3, which is adding 3 to both sides. 2p equals 3. And dividing both sides by 2, p equals 3 over 2. Now that I have those, I can come up with the two prices. These are actually the prices, p. So price 1, that's going to help me break even, is going to be, as a dollar value, 5 divided by 2, which is $2.50. And the price 2, that's going to help me break even, is $1.50. But this was really only one way to do this equation. This was kind of something that we learned in the last unit. But we are on the systems of equations unit. So what does that mean? Well, we could have actually just went and said, when the revenue, let's say the revenue equals Y. In other words, the revenue must equal the cost. So Y equals the revenue, which equals the cost, because that break-even point is where these are equal. So we're just going to substitute this value of Y for R of P and C of P. In other words, I get Y equals negative 20p squared plus 50p. And then on the other end, I get Y equals 75 minus 30p. Well, now we can actually go ahead and substitute one of these values of p into the other one, or Y, I mean, into the other one. So I'm going to take this one and substitute it into there. Let me rewrite that again with red so it shows up. So this part here, we're going to substitute in here. Well, that really just gives us what we did in that quadratic side. So in this one, I'm going to subtract 75 from both sides. And I'm going to add 30p to both sides. So this is going to give me 20p squared plus 50p plus 30p. I'll write it all out. Which is going to give me 20p squared plus 80p minus 75 equals 0. Well, look at what we got. So by thinking of it as a system of equations, we still ended up with the same quadratic that we had to solve. And I won't go through all this work again, but now we have the same two final solutions. So let's verify this. Let's start by taking P equals $2.50 and substituting it into both equations. So if R of P equals 250, or sorry, let's write this out in nice function notation form. So if R of 250, that's going to equal negative 20 times 250 squared plus 50, I'm running out of room, times 250, like that. Well, that's going to equal, plugging it all into the calculator, is equal to negative 20. Now this little number here is 6.25, so 2.5 squared is 6.25, plus 50 times 250 is 125. Now we got this negative 20 times 6.25, which is negative 125, plus 125, which equals 0. It's kind of what we thought because we knew this was a break-even point. So what would the cost be? Let's check it out. The cost is 75 minus 30 times 250. So this is going to be 75. Now 30 times 250 is 75, which is 0. So in other words, when the price is 250, there's 0 profit. But notice, they spent 0 money and they took in 0 money. So the cost was 0, but also the revenue was 0. So this 251 doesn't kind of make sense, does it? Let's look at the $1.51. So no money came in and no cost went out. Let's see if we have any better luck with the other one. So let's find the R of 150. So we put that in, and what do we get? Well, we get negative 20 times 2.25 plus 50 times 1.5, which is 75. And here we get negative 20 times 2.5, which is negative 45, plus 75, which is 30. Okay, so if the shaker price is $1.50, the revenue that comes in is $30. But let's look at the cost. So the cost is 75 minus 30 times 1.5. So that's 75 minus 45, which equals 30. Now that kind of makes a little more sense. Whereas this one, there was 0 revenue and 0 cost, which is 0 profit. Here, if we take in $30, we spent $30 and now there's 0 profit. So this one here makes sense. So if the ticket is $1.50, they will make 30, but they will spend 30. Okay, one more to go. Now, another one of these problem-solving type of questions. It says determine two integers who the sum of the smaller number and twice the larger number is 46. But when the square of the smaller number is decreased by 3 times the larger number, the result is 93. So what we have here, we have two sentences that describe two different situations of these two integers. Let's call x, we're going to let that be the smaller number. And we're going to let y be the bigger number. Now let's make these two things into two mathematical statements. It says the sum of the smaller number, well, sum is add, and the smaller number is one of them, is added to twice the larger number. So the bigger number is that, y, so we're going to say 2y, and that is going to equal 46. But the other one is the square of the smaller number. So now we're squaring this thing. And we're subtracting 3y, and that's going to give us 93. So 3 times the larger number minus 3y. So decrease by 3 times minus 3y. So now let's solve these things. Well, the first thing we want to do is we want to line these things up. We want to make the x squared equal in one line, the x's and the y. So let's go ahead and make x plus 2y equal 46. And I'm going to put my x squared way out here. I don't have an x term in the second equation, so I'm just going to leave it blank. And I'm going to put a 3y right there. And there we go. Now remember, we have to deal with the y's when we have an x squared term in terms of multiplying it to make the y's cancel. We could use the substitution method in this case, but I think the elimination will be a lot nicer. Well, for these y's to have the same coefficient, I would have to multiply this equation by 3 and this equation by 2. So remember, it's like I'm taking each of these things and I'm distributing the 3 all the way through. And then I'm doing the same thing with the 2. So when we do this, we want to make sure that we capture all the terms. I'm not going to have to multiply one of these by a negative number because notice the y at the second one already has a negative in front. So let's go ahead and distribute those numbers through. And so I get 3x plus 6y equals 46 times 3, which is 138. Do it again with the 2 on the second equation. I get 2x squared. I got nothing here in the x term, but I got this minus 6y here. And 93 times 2 is 186. So what did we do so far? We lined them up. And now, and then we multiplied. Oops, I got that in the wrong spot. One, two is multiply, and then eliminate the y. So adding everything together, 2x squared, there's nothing up here, so it's 2x squared. 3x plus, there's nothing down here, so it's 3x. These cancel, and I'm left with 138 plus 186. So this is going to give me 324. Well, let's go and make this look like a quadratic in standard form by subtracting 324 from both sides. So I get 2x squared plus 3x minus 324 equals 0. Now, factoring this is not going to be fun. We got a huge number here, this 324. So what do we do when factoring's ugly? We break out the big guns. So here we're going to get negative 3 plus or minus the square root of b squared, that's 3 squared, minus 4, times a, which is 2, times c, which is negative 324, all over 2 times a, which is 2 times 2. So that gives us 9. A negative 4 times a positive 2 times a negative 324, that's going to be adding. So I'm going to add 4 times 2 times 324. I'm going to put that in my calculator. And you get 2,592 all over 4. Now this is going to give us negative 3 plus or minus the square root of 9 plus 2,592. That gives us 2601. And you're probably thinking, oh, terrible number for square rooting. But it's not. This one actually equals negative 3 plus or minus 51. Surprise, it came out really nice. So this could be factored, just wouldn't have been fun. So now we have our two solutions. The first one let me just give some space, is negative 3 plus 51 over 4. So that's our first value of x. And that's going to give us 48 over 4, which equals 12. Cool. That worked. Let's try the second one. That's when we subtract everything. We get negative 3 minus 51 over 4, which equals negative 54 over 4, which equaled negative 13.5. Now, while it's not a repeating number, remember that these things are integers. So in a question, the context is important because sometimes that's going to eliminate some potential solution. So in this case, our x cannot equal 13.5. So that means when we want to, so this was our find x, and our last step now is to find y. So we're going to use this 12 to find that y, but we're not going to use the negative 13.5 because even though there is going to be an associated y, it doesn't matter because negative 13.5 is not going to work. So x plus 2y, let's use this one. Let's substitute in our 12. We're going to subtract 12 from both sides. And that gives us 2y equals 46 minus 12. That is a 34. Dividing both sides by 2, we get y equals 17. So the solution set here is only one solution despite the fact that we do have a quadratic. It's 12 and 17. So let's verify the solutions. So the small integer is 12, and the large integer is 17. Now let's go ahead and we're going to verify that. Now to verify, remember, we're going to have to test it in both of the equations. So the first equation was x plus 2y equals 46. So when x equals 12 plus 2 times 17, we get 12 plus 34, which equals 46. So that one worked. Let's test the other one there. We got x squared minus 3y equals 93. Putting in the 12 squared minus 3 times 17, we get 144 minus 51. And we get 93. And we're done. Well, now it's time for you to continue practicing. Remember that anytime you run into trouble, be sure to get in contact with your teacher. They would love to hear from you. That's the end of our lesson. I hope you have a great rest of your day. Take care.